7 engines roared together for the first time, unleashing nearly 1,000 tons of thrust at China's Wenchang launch site. This wasn't just a test, it was the debut of the Long March 10's powerful core, the rocket set to carry astronauts to the moon. Today, we'll explore what happened during this milestone firing and what it means for the next giant leap in space exploration. On August 15, 2025, at the LC-301 launch pad in Wenchang on Hainan Island, China's space program achieved a new milestone: the first static fire test of the Long March 10 rocket's 7-engine first stage. For about 30 seconds, the engines blazed in perfect unison, producing nearly 1,000 tons of thrust, the largest static ground test China has ever conducted. The engines powering this achievement were the YF-100K, an advanced upgrade of the proven YF-100 kerosene/liquid oxygen design already flying on the Long March 5, 6, 7, and 8 families. Each YF-100K can generate about 130 tons of thrust at sea level, and for this test, engineers mounted 7 in parallel to simulate the actual flight configuration. In total, the cluster produced more power than any rocket stage China has ever ignited on the ground. This test wasn't held at a remote stand, but on the actual launch complex where future missions will depart for the moon. That's significant because it validates not just the engines themselves, but also the pad systems, cryogenic fueling lines, flame trenches, water suppression, ignition control, and structural supports. By firing 7 engines simultaneously, engineers collected a mountain of data on how the engines operate together: ignition sequencing, fuel distribution, gimbal control, engine swiveling for steering, pressure stabilization, and acoustic vibrations. Why does this matter? Because clustering engines increases complexity dramatically. A single misfire, imbalance, or unstable oscillation could compromise the entire stage, demonstrating synchronized ignition under both nominal and high-power modes. As China Manned Space Engineering Office proves, the design can handle extreme conditions. The ability to test these limits safely on the ground is a cornerstone of reliable human-rated launch systems. So why is this 7-engine test more than just another milestone? To answer that, we need to understand the scale of the Long March 10 itself and why this vehicle is unlike anything China has built before. Standing at 92 to 93 meters tall, the Long March 10 is a 3-stage super heavy rocket. At liftoff, it will use 21 YF-100K engines firing simultaneously, 7 on the central core and 7 on each of 2 strap-on boosters. When fully fueled, this powerhouse will generate a combined thrust exceeding 2,600 tons, nearly tripling the power of the Long March 5, China's current largest rocket. That thrust is what makes it possible to launch crew and cargo toward the moon. In fact, the Long March 10 is expected to carry around 27 tons of payload into a trans-lunar injection trajectory, the exact requirement for ferrying the Mengzhou crew spacecraft or the Lanhua lunar lander. Without this class of rocket, a crewed lunar mission simply isn't possible. The August static fire is so special because it validates the core first-stage cluster, the heart of this system. Earlier, in June 2024, engineers fired a 3-engine configuration producing about 382 tons of thrust. While that test confirmed ignition sequencing and basic thrust balance, this 7-engine trial nearly tripled the complexity. Synchronizing ignition across 7 large combustion chambers requires precise timing, stable turbopump operation, and perfect propellant flow. By achieving this on the pad, China proved that its scaling strategy is working. There's also significance in the fact that the YF-100K itself is not an experimental design, but an iterative upgrade. It has enhanced performance, longer life, and reliability improvements over the YF-100. Using this evolutionary approach reduces risk because the engines have flight heritage. What's new is the scale of clustering and how that integrates into a launch vehicle the size of Long March 10. Beyond numbers, the Long March 10 represents a modernization of China's human spaceflight capability. It will replace the Long March 2F, which has launched every crewed Shenzhou mission since 2003. The static fire was spectacular, but it's only one milestone on a carefully charted roadmap. To understand what's coming, we need to look at China's phased approach to developing the Long March 10th and its associated lunar mission architecture. According to CMSCO and spaceflight reports, the 7-engine firing was the second of 4 planned development stages. The first was the 3-engine test in 2024, which validated clustered ignition on a smaller scale. The second, this August 2025 trial, proved 7 engines could work together reliably. The third stage will be a low-altitude flight test, designed to evaluate ascent dynamics, booster separation, and possibly early work toward stage recovery techniques. The fourth stage will be a full orbital launch, the ultimate rehearsal before the rocket is declared flight-ready for lunar missions. Parallel to this, China has been testing the other hardware needed for lunar exploration. The Mengzhou spacecraft, which will carry astronauts, has undergone a pad-aboard escape test, demonstrating that crews could be saved if something goes wrong at liftoff. Meanwhile, the Lunar lunar lander has completed landing and ascent demonstrations, proving that it can touch down and then return to lunar orbit for rendezvous. Together, these elements form a coherent system: rocket, spacecraft, and lander. Here's how the mission will work. 2 Long March 10th rockets will launch separately. The first carries the Mengzhou crew capsule. The second delivers the Lunar lander. Once both reach lunar orbit, they dock. The astronauts transfer to Lunar, descend to the surface, conduct their mission, and then ascend back to dock with Mengzhou for the return journey. This dual-launch architecture balances payload limitations with mission safety. Looking further ahead, Long March 10th will also be critical for building the International Lunar Research Station, ILRS, a multinational project led by China and Russia, planned for the 2030s near the lunar South Pole. While the Long March 10th handles crew and medium-sized cargo, the even larger Long March 9th, still in development, will be used for heavy logistics. Think of Long March 10th as the bridge, powerful enough for first lunar landings, scalable enough to support early outpost construction, and versatile enough to replace the aging Long March 2F for all future human missions. The 7-engine static fire at Wenchang wasn't just another test. It was a declaration that China's lunar program has moved into a new phase of reality. For the first time, engineers proved that the powerful YF-100K engines, clustered in a configuration destined for the Long March 10th, could ignite and operate smoothly, producing nearly 1,000 tons of thrust. That's more than a number. It's the clearest signal yet that the backbone of a crewed lunar rocket is now in place. But what makes this moment truly historic is how it fits into the bigger picture. Alongside the Long March 10th, the Mengzhou crew spacecraft has already demonstrated its escape systems, while the Lunar lunar lander has passed landing and ascent trials. Piece by piece, the essential components of a lunar mission are being validated. When these systems finally converge, China will be positioned to attempt its first crewed moon landing around 2030. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.